In this lesson, we will learn how to evaluate powers with a zero exponent, as well as how to evaluate a power with a negative exponent. So let's just refresh our memory with just exponents and what they mean. So remember, exponents is just repeated multiplication. So we have a base of 3, and we have one of those 3's. Then we have 3 squared, which is 3 times 3, and that gives us 9. And then we're going to keep repeating times 3. So 3 to the third is 27. 3 to the fourth is 81. And 3 to the fifth is 243. So exponents just means repeated multiplication. Now let's go backward and see what happens. So instead of going 3 to the first, 3 to the second, let's go backward and see what happens. When we are decreasing a negative exponent, the pattern is to divide by your base. So now we have 3 to the fifth, we know is 243, and we're simply going to undo the repeated multiplication and divide by 3. So 3 to the fourth is going to be 81, because 243 divided by 3 is 81. And then when we divide 81 by our base of 3, we're going to get 27. 3 times 3 times 3 is 27. And we're going to keep going down, dividing by 3. 27 divided by 3 is 9. Therefore, 3 squared is 9. And then we're going to take our product of 9 and divide it by the base of 3. And we have 9 divided by 3 is 3. And we know 3 to the first is 3. We're going to use this pattern to discover when we have a power that has a zero exponent. So let's continue the pattern going from right to left and decreasing our exponent, which we know the pattern is to divide. So we know 2 to the fourth is 16. Now let's continue the pattern. We're going to divide by our base of 2. 16 divided by 2 is 8. And we know 2 to the third is 2 times 2 times 2, which is 8. So again, let's just keep going to see what happens as we continue to divide by the base of 2. 8 divided by 2 is 4. Therefore, we know 2 squared is 4. 4 divided by 2 is 2. 2 to the first is 2. Now, let's see what happens. We have 2 to the 0. So remember, you're just dividing by your base as you are decreasing the exponent. 2 divided by 2 is 1. So 2 to the 0 is 1. 2 to the 0 is not 0, it is 1. So let's go here. So we have 4 to the fourth, which is going to be 256. 256 divided by 4 is 64. Then we're going to take 64 and divide it by the base of 4, and we get 16. Therefore, 4 squared is 16. Let's take 16 and divide it by our base of 4, and we get 4. 4 to the first is 4. Now look, 4 divided by 4 gives us 1. So what do you notice? When any base is raised to the power of 0, we get 1. The reason that we get 1 is because raising a power of 0 really means the base divided by itself. You can see here, 4 divided by 4 is 1. 2 divided by 2 is 1. So in your notes, make sure you write your exponent rule of when you raise a base to the power of 0, you always get 1. So let's try 4 examples together. 12 to the 0 is simply 12 divided by 12, following our pattern, and we get 1. Example 2, notice that our negative is included as with our base. So our base is negative 12, and the pattern would be to divide it by negative 12, and we get 1. Example 3, be careful. This negative is not included. The base is actually 12 raised to the 0. So we have negative out front, and then we have 12 divided by 12, and that gives us -1. So be careful between these two types of problems, which you learned in lesson 1-1. Now we have some value x raised to the 0. So again, it's the pattern, and you're just dividing it by itself, and we get 1. Now let's take a look at some examples where we are continuing to have a decrease of exponents. So again, we're just going to start and use our pattern of division. We know that 2 squared is 4. We divide it by the base of 2 and we get 2. We know 2 to the first is 2. We're going to divide the 2 by the base of 2 and get 1. Again, we know now that 2 raised to the 0 is 1. So we're going to keep going with a pattern. So we have a 1, and we're going to divide it by 2. 1 divided by 2 is simply 1/2. So what do you notice here? We have a negative exponent, and we get a rational answer, 1/2. And then we're going to keep going, and we're going to have 1/2 divided by 2. 1/2 divided by 2 is the same thing as multiplying by 1/2. So we get 1/4. 2 to the -2 is 1/4. We have 1/4 divided by 2. Dividing by 2 is the same as multiplying by 1/2. So that gives me 1/8 for 2 to the -3. So let's take a look here and see what's happening. We notice, if you notice, 2 to the -1/2 and 2 to the first are reciprocals. The same thing for 2 squared and 2 to the -2. They are reciprocals. So as you can see, as my exponents decrease, my values decrease. Let's try the powers of 4. So 4 squared we know is 16. We're going to divide it by 4 because we're decreasing. And we know 4 to the first is 4. We're going to divide 4 by 4, which gives us the rule of when we have a 0 exponent, that gives us 1. We're going to divide 1 by the base of 4. 1 divided by 4 is 1/4. Again, notice the reciprocals here. And then we're going to divide 1/4 by 4. So dividing by 4 is the same as multiplying by 1/4. That gives me 1/16. Another pair of reciprocals here. And then we're going to keep going and divide by 4. And if this was 4 to the third, we would have 64, because 4 times 4 is 16, times 4 is 64. And because we have a negative exponent, we know we're going to have a rational number. So we're going to have 1/64. So here is the rule. When you have a negative exponent, you're always going to reciprocate the base. So we're going to take x to the -m, and we're going to reciprocate it and put it in the denominator. And then if there's nothing left, we have to put a 1 as a placeholder here. Okay, so here is your rule. So we have 7 to the -2. I'm going to first simplify and get rid of the negative by moving my 7 to the bottom, and now my exponent becomes positive. And then if we expand it, we get 1/49. Example 6, the base is a -7. The negative is included. So we're going to get rid of my negative exponent. We're going to take -7 and move it to the bottom in our denominator, and then our exponent becomes positive. So we have -7 times -7 in our denominator. So we have 1/49. Number 7, notice this base is 7 to the -2. This negative on the base, you can just bring it out front. I'm going to evaluate and get rid of my negative exponent by moving my base of 7 to the denominator, and therefore my exponent becomes positive. I'm going to expand my power of 7, so I have negative 1 over 49. And now we have some value raised to the negative 3. We want to evaluate and get rid of this negative exponent. So we're going to reciprocate x to the negative 3 and make it x to the positive 3. So our final answer is 1 over x cubed. So remember, when you have a negative exponent, you move it to the denominator if it begins in your understood numerator here. Because now we're going to take a look at the negative exponent rule also applies when we have negative powers begin in the denominator. So you typically do not want a negative exponent. So anytime you're asked to evaluate a power and it has a negative exponent, you're going to need to reciprocate it. So because I have m to the negative n in the denominator, to get rid of or simplify the negative exponent, we're going to reciprocate that power up to the numerator, and then we no longer have a negative exponent. So for example, number 9, to evaluate this negative power of 3, we're going to bring m to the numerator, and 1 times m cubed is m cubed. Now, on example 10, in the numerator, we have a negative 4. We need to reciprocate this power of h and bring it to the denominator. Then the denominator in our original problem has a negative exponent, so we're going to reciprocate the base of b to the numerator, and now we no longer have any exponents. So you're just moving the powers that have a negative exponent to the opposite location of your expression. So k to the negative 2 needs to be moved to the denominator. Z to the 4th is in the denominator and it has a positive exponent. You just need to keep it where it is. Now, we can't leave a rational expression with nothing in the numerator, so you'll just put a 1. Example 12. We are going to reciprocate both of these powers because they both have negative exponents. So 2 to the negative 3 comes to the denominator and becomes a positive exponent. 3 to the negative 2 will reciprocate to the numerator. And now let's evaluate these. Anytime you can evaluate, go ahead and do that. So here we have 9 over 8. So let's just leave it as 9/8. Now, you need to finish up and practice 1 through 28 on your own.